well. All right.
Thanks, everyone. Welcome back. I would love to welcome Cy Venom from AWS, who's going to show us how EKS Auto Mode and Chainguard images work together. Cy, take it away.
Awesome. Thank you, Mandy. Hello, everyone. My name is Cy Venom, and I'm a Principal Solutions Architect at AWS. If you know me or you've seen me on YouTube before, you know I like doing demos. Usually my talks are demo focused. So I only have 15 minutes today, so I'm going to get right into it. Just quick 5 seconds about me. I live in Austin, Texas. I've been at AWS for about 5 years now, and I've got my Texas Amazon shirt on right now as well. All right, let's get into it. Today we're going to talk about deploying secure containers on EKS using Chainguard images, and hopefully at the end of this you'll understand how these two solutions kind of fit together. Of course, Amazon EKS being Elastic Kubernetes Service, a service offered by AWS to help you run managed Kubernetes. And look, this is something that most of us understand in the Kubernetes world, whether we're developers or operations. Kubernetes can be hard. You have to provision the control plane, manage the compute, manage all the add-ons and plugins. Here's where Chainguard comes in. You have to actually build an application with its dependencies, those kind of things, and then monitor those applications and optimize them as you move forward. There's a lot when it goes into Kubernetes operations. So very recently, AWS announced an all-new capability called Auto Mode. We announced this at reInvent last year, and essentially helps you automate your Kubernetes stack. The key change here with Auto Mode is we're really managing more of the cluster for you. So things like upgrades become easier, keeping your applications secure and the operating system patched is easier. And there's a whole lot more there. But again, I want to get into the demo today and show you exactly how Auto Mode and Chainguard fit together. Really, with Auto Mode, there's one straightforward way to think about things. You start from creating a cluster or changing your existing EKS cluster to be Auto Mode. Whenever you deploy a workload into an Auto Mode cluster, it'll automatically provision the infrastructure. It'll even dynamically scale the underlying nodes, right? The EC2 instances in response to the workloads that you're creating. And of course, continuously optimizing for cost and helping you keep your cluster up to date. Okay, so that's the AWS side of the picture. Let's talk about the Chainguard side for a second. So Chainguard containers make it a lot easier for developers and ops teams to keep their workloads secure at the application layer. I've referenced layers quite a bit, and I think my next slide is going to help bring it together a little bit of what I mean by these shared responsibility layers when it comes to running workloads in the cloud like AWS. So with Chainguard containers, it's powered by an undistro, essentially a really lightweight Linux distribution that they call Wolfie. They get very close to zero CVE or sometimes zero CVEs through daily updates. And for a lot of customers, the certain benefits here with compliance, like FIPS enforcement, can be really meaningful, or sometimes even a requirement. And it's easy to drop them in. And so that's what I want to get into today, and talk exactly about why Chainguard containers are easy to use, how they can be kind of dropped in. So the first thing I want to show you folks is kind of some images that I had built already, and I pushed them into a container registry. I used Amazon Elastic Container Registry, or ECR, to host these images. These are pretty straightforward images, right? So there's a simple Python application that I have. It's a fast API application. It uses the latest tagged version of Chainguard's Python image. And notably, I'm using the -dev, which is not quite as minimal as the full lightweight Python image, but it gives you some tools that I needed to build the application itself. And I also have another Docker file which uses the basic default Python 3.12 Slim from the upstream version. And I want to show you folks a couple of things really quick right off the bat of when I built those images. You'll notice that Oh, of course, Docker is down. We'll start that back up, and it'll come up in a second here. We're doing this live, folks. But here we go. Docker's getting started up. In a second, it should load up. And here we go. Okay, so I've got a lot of images here. So I just want to point out two really quickly. The default Python image here, nearly twice as big as the Chainguard image. And by the way, if I was using not Chainguard-dev, but the lightweight version of the Chainguard image, I think this would be somewhere around 50 or 60 megabytes. So that's one thing, the size of the image, but that's not everything, right? It's about vulnerabilities, and that's what I want to get to here in a minute. Okay, so those are the Chainguard images. I'm going to quickly switch context here. This is my browser. You can see here that, here, let me just hide this so we have a little bit more space. You can see this is kind of available to use for anyone. These are the Python images that I'm using in my Docker file. They have the latest and latest-dev. But let me switch to my AWS account. And I want to show you the experience that we've created with Amazon EKS auto mode. I've got a couple of clusters already running in the account that I'm going to use for the demo today at Chainguard-demo and Chainguard-demo 2. We usually don't show the console in demos here at AWS, but I got to talk about this because it's kind of a new approach to creating clusters, and it really simplifies things. So it's called quick configuration. It's a quick create flow for EKS clusters, and by default, it uses auto mode. You can always go through the other 6 steps to fully configure your AWS cluster, but we really wanted to streamline this experience of creating a Kubernetes cluster and deploying workloads to it that can actually be accessed. So in the quick create flow, you can see you can configure things like the name of the cluster, the Kubernetes version, the cluster IAM role and node IAM role. We have a handy button to just create it for you. We really don't want you to get stuck on creating something like your first cluster on AWS. A VPC, usually you'll use a default one, but for this case, I created a Chainguard demo VPC, and it'll give you some subnets for where your pods run as well. That's really it. If I hit this create button, it'll create that Kubernetes cluster for me. And I can even hit this refresh button to find a nice name. Peculiar Lo-Fi Mongoose. Okay, awesome. I could create that cluster right now by just hitting the create button. And might as well do it. I'll hit create. All right. Now that we have a cluster being created, maybe I should switch to one that's already there just so we can move a little faster. So here's what we'll do. Let me just make sure that I'm on the right cluster. So I'm going to do a get pods, and this cluster should have nothing in it so far. By the way, this is something that's really interesting. If you work in the world of Kubernetes, you'll know running kubectl get pods -a gets all of the pods in the Kubernetes cluster in all the namespaces. And it says no resources found. In fact, if we do a get nodes, it'll also say no resources found. So by default, an auto mode cluster comes with no underlying compute, and all of the pods that you might previously expect to need, like the container network interface, a CNI, or kube proxy, or a number of these other components that you might typically need to manage yourself, are now running on the AWS control plane. Okay, essentially that means you don't have to manage these components anymore. And when you try to deploy a workload, it's going to automatically create the nodes for us. So very quickly, and I'll just show you what that deployment looks like. One of them is a Chainguard deployment, which uses the Chainguard version of the image that I showed you folks earlier in the Docker file. And the other one is a Python version, a default version of that same image, which doesn't use the underlying Chainguard images to build. Okay, now that we have that, let's go back into my terminal. And what I'm going to do is apply those two files. So I'm going to apply dockerfile.chainguard. Oops. Let's see. I think I changed something right before the demo. Let's see, give me 1 second. Oh, that's right. I'm applying the wrong file. Here we go, K8. Again, folks, we are doing it live. Here we go, applying the right file this time. By the way, down here, you'll notice I have another window open. And it said there were no instances running. But as soon as I applied that Kubernetes config, it spun up a node. This is one of the cool things about auto mode. It uses Carpenter underneath the covers, which is an open source project contributed to CNCF by AWS. It responds to pods that need to be scheduled by spinning up a node that can fit that pod. And let's go ahead and apply the other one as well. Python dash default. And okay, you can see that the pods are coming up. It's spun up a node to actually support that workload. And I think we're basically good. In a few seconds here, I'll get a service link that I'll be able to hit. And that will look something like this, where we have a fast API app for these workloads. Okay, so far so good. But how do I know that these images are more or less secure, right? That's the story at the end of the day. Well, we'll go back into our AWS console and we'll go to ECR, Elastic Container Registry. ECR will automatically scan container images that you've pushed into it. So this is why I made 2 versions of that image, one using Chainguard underlying images and one using the default Python upstream image. Let's take a look. So I have those 2 images right here that, if you'll remember, I referenced in my Docker file. If I look at the default image, and I'll open this in a new tab, let's see how many vulnerabilities it finds. Okay, so 1 critical, that's already not great. And it explains exactly what that vulnerability is. And I don't know if anyone can do some quick math here, but this is looking like about 170, 180 other issues. And with ECR, you can even click this button to dive deeper, dig into what those vulnerabilities actually are. And essentially, you probably want to use a different image if you see this many CVEs on your base image. All right, let's go back to Chainguard. Let's look at the Chainguard dev image that I used. Yeah, that's a lot fewer. For most importantly, we don't see a critical issue. None of the lower info issues pop up, and I see 1 high and 1 medium, and I can dig into these as needed. Really, that's the power of using Chainguard images. It's essentially being able to be secure from the ground up. I really do suggest using these type of images, whether you're working in dev, starting out, or you're kind of more mature. I talked about the shared responsibility model earlier. I'll just bring it back to it really quickly. Previously with EKS, these are all the components you had to manage. And I'm just going to flip back and forth. On the second slide here with EKS auto mode and then Chainguard, which you can see on the top right here, we really reduce the amount that you as a customer need to manage. Again, you can kind of see here with EKS, previously you were responsible for managing the underlying EC2 instances and cluster capabilities like auto scaling, load balancing. With auto mode, those are managed for you, and Chainguard even helps you manage the application layer here where you see at the top right with the container images themselves. Okay, folks, I tried to pack a lot into that 15 minutes. I think I'm right at 14 minutes now. My name is Cy Venom. You can find me here on LinkedIn or check us out on Containers from the Couch. If you have any questions, I'm sorry we didn't have any time to get to questions today, but feel free to reach out directly, and I'm happy to chat. I'm going to put on my Mandy impression and thank everyone for joining us today. I'll see you around. Be sure to reach out.
That was a great impression, Cy. Thank you. We'll see you in the next session. Be sure to join from the agenda tab. We'll be back here at 15 after the hour. We're going to take a short break, stretch your legs, get some coffee, and make sure you're not muted when it's your turn to present.
Love it. Awesome. Thank you.